Okay, so this video is for Monday, March 2nd, or excuse me, March 1st lesson in Algebra 1. So I'm actually finishing up section 4.1 where we cover inequalities. I have a couple of additional problems to work through that are not in your book, but will cover a lot of the main ideas that we talk about in this unit. So go ahead and have your paper ready. You don't necessarily need your book open at this point, but have your paper ready to jot these down as I work through them. And then we're actually going to move into the homework problems and finish working through those as well. So these are, a pen working. In section 4.1. Okay. So for 1, 2, and 3, I would like for you to write an inequality equivalent to the given inequality. So remember, one of the things we learned about in this unit were sort of negated inequalities where you have the line crossed through it. So if I give you x is not less than 7, how would you write? I would think this is I would call this like a negative inequality. How would you write this as a positive inequality? Just not in terms of the value of the integer, but just in the way that you're expressing the inequality. So in this case, if you said this, you would say x is not less than 7, right? You've got that not in there, that negative. So the other way, another way to say the exact same thing would be to say that x is greater than or equal to 7, right? So you can sort of make it like an if-then statement. So if x is less than 7, then it must be greater than or equal to 7. Did I say that right? If x is not, yeah. So let's do another example. So if I give you x is not greater than 4, then you could re-say that, re-express that as x is less than or equal to 4. So remember, if you're not inequality, if your negated inequality does not have an equal to portion of the greater than or equal to, then your equivalent must, and vice versa. So this one is a good example of that. So if I say that x is not greater than or equal to -2, then you must say that x is only less than -2. So sorry, I forgot the negation there. So if x is not greater than or equal to, then that means it's not more than -2 and it's not equal to -2. So it must be less than. Okay, logically, hopefully that makes sense. But it can get a little confusing trying to communicate mathematical operations like this. So I'll try to keep my words straight. Okay, so for number 4 and 5, all we're doing is we're answering a yes or no question, determining whether 3 is a solution to each inequality. Show you what I mean. So let me put that down. Is 3 a solution to each inequality? Number 4 states that 3x minus 2 is less than 7. So when it asks the question, is 3 a solution to this inequality? What it's asking is, if you plug the value of 3 into the x variable and solved it, would you have a true statement? So let's do that. So 3 times 3 minus 2 is less than 7. So let's simplify. 3 times 3 is 9. 9 minus 2. Hopefully you can see where this is going. So is 7 less than 7? No, because it's equal to. So this is false, or no, 3 is not a solution to this inequality. All right, let's look at number 5. same thing. We're asking if 3 is a solution. So if I said 3x is not, is not greater than 12. First off, I would immediately turn this from a negation into a positive statement. So I would switch, pretty much all you're doing there is you're flipping your inequality sign and adding a greater than, because in this case it's not there. So instead of saying 3x is not greater than 12, then I would say 3x is less than or equal to 12. Now I need to plug in the value of 3 for the variable x and solve it to determine if it's a true statement. So 3 times 3 less than or equal to 12. We know 3 times 3 is 9. We also know that 9 is less than 12. So this is a true statement, which means yes, 3 is a true solution to the statement, or to the inequality 3x is not greater than 12, because it's 9 and that is less than. So we're good. Okay. All right. So the numbers 6 through 10, we're going to graph an inequality on a number line. So these are just graph. Number 6 is y is less than 7. So create your number line. I don't like to have them too complicated. Also, you know that you've got to start your number line with the constant that they've given you in the inequality. So I just put that in the middle. So I'd make this 7, 8, 9, 6, 5. That keeps it simple, gives you room to keep it neat, and you can still kind of prove the inequality statement. So remember, because, hold on. All right, so because this is not a less than or equal to, the circle that you put at 7 must be open, because remember that means it starts at 7, but it does not include 7 as a correct solution. So then you sort of follow the arrow, as long as you've got your variable on the left-hand side, and you know that it goes left, which is all the smaller numbers. So y is any number less than 7. All right, number 7 is y is greater than or equal to -2. So we draw our number line. Put a couple of tick marks on there. Throw your -2 somewhere close to the middle. So this one's -3, -4, -5, -1, and 0. All right, so we're going to put our circle at 2. Is it open or closed? Hopefully you see that because the equals to is part of the greater than or equals to, that we close the circle because it's included in our solutions. And then y is greater than, so it means it's any number with a higher value than -2. So you would draw your arrow to the right. All right, so keep doing that for the last few. I could pause this and see how you do once I give you the values. We have x is less than or equal to 6. Number 9 is x is not equal to 0. And then we have 10, which is x is greater than 8. All right, so when we put these on a number line, there's no need for me to make it that long, but here we go. I'll just space them out. All right, so I'm going to put 6 in the middle. 5, 4, 7, 8. We start at 6, and in this case, it is open, or excuse me, it's a closed circle because it's equal to. So 6 is a solution. And then it's less than or equal to, so you would draw your arrow to the left because it's any number less than 6. Hopefully this comes very easy. We've woken up all of those brain synapses from when we learned this back in our arithmetic classes. 1, 2, -1, -2. Okay, so if we say that x is not equal to 0, then we're saying that x is equal to everything but 0. We don't really have a sign for that. So we do leave the negate negation in this symbol, this inequality. But you want to make sure that the circle at the 0, the dot that you have is open because it does not include it. And then your arrows draw in both directions because every number except 0 is included. So it's got to go everywhere but 0. All right, now last one, number 10. We have x is greater than 8. So put 8, 7, 6, 9, 10. We put our open circle at 8 because it's not included as a true statement or true solution here. And then x is any number greater than 8. So your arrow goes to the right. Okay, so just a little extra. Let's jump back into the homework, which I believe I ended Friday with number 23. So I'm going to pick up on number 25. So the homework assignment for this, which we were able to do in class on Monday, so you should be able to do it all at one time, is number 25 through 33 odd. Okay, so let me get on the right page here, and that is on page 147. All right, so on number 25, we are right in the middle of graphing inequalities that they've given us. So on a separate number line, so each one's on their own number line. So 25 is x is less than or equal to 1.2. So doing this on a number line, you can pretty much make your tick marks whatever value you want. So if they give it to you in decimal form, just keep them all in decimal form. So if this one is 1.2, this one's 1.3, if I can do it right, 1.4, 1.1, 1.9, right? Just leave it like that, that's fine. Okay, so we are starting our number line on, starting our graph at the 1.2. And because the equals, it's less than or equal to, then that's a closed circle because that is included in our solutions. And then it has to be any number less than. So we draw our arrow down to the left. All right, 27. Okay, 27 is 100 is less than or equal to x. So 100, 99, 98, 101, 102. Okay. Now in this case, 100 is less than or equal to, so it's included in our true solutions. And then we also continue the graph to the left to include every number less than 100. Hopefully this is super easy. I think this is why we breezed through it so quick in class. Okay, so number 29 gave us x is greater than 1.5. Right, so again, don't let yourself get too distracted by the decimal points. Just make sure that your number line indicates accurate numbers. Let's see, 1.4, 1.3. Okay. All right, so start your graph at 1.1.5 on the number line. It's an open circle because it's not included in our true solutions. Then it's any number larger than. So just move on to the right. And there's your graph. All right, last one for this section, and then we'll move to some that are a little more challenging, hopefully. Okay, so 31 is x is not greater than 0. So just like I did in the additional problems earlier, I would turn that negated inequality into sort of what I call a positive inequality, so it doesn't get too confusing. And I would change that to x is less than or equal to 0. 1, 2, 3, 4, 5. Victor, please remember you're being recorded. I do. Sorry, I'm at home, so there's a lot of background noise. 0, -1, -2, 1, and 2. All right, so we start at 0. It's a closed circle because 0 is included, and then it's every number less than 0. So we're going to the left. Okay, so for number 33 through 37, we are given, I know y'all hate these, we are given an inequality that's written out, and we are being asked to, number one, define our variable, which just means pick a letter and then make sure you understand what it's representing, and then write it in an inequality, modeling the situation they're describing. All right, so for number 33, it says, you must be at least 18 years old to vote. So you can pick your variable, I like X, and we know we're comparing it to 18. All right, now X stands for the age requirement, the voting age is what I would call it, right? So the voting age must be at least 18. That means it can be 18. So you've got that or equal to portion. But the question is, can X be, should it be less than or equal to 18, or must it be greater than or equal to 18? And of course, in this case, you've got to be older than 18. So it's greater than. So that's really all they're asking for, is that you create a variable and write it in a correct inequality. So that's our answer. X is greater than or equal to 18. 35 states the maximum wattage is 60 watts. So you can pick W. W is your wattage. You're comparing it to 60 watts. And it's saying that the maximum wattage allowed is 60, which means it can be 60. So you would have that equal to portion included. But the question is, should the watts be less than or equal to 60, or must they be greater than or equal to 60? Well, if it says the maximum is 60, then that is the most it can be. So it can be less than, but it should not be greater than. That's why this is the wattage is must be less than or equal to 60 watts. Okay. Number 37. So 37 says the Institute of Medicine recommends a minimum daily intake of 75 milligrams of vitamin C for women. So variable X is the dosage or daily intake of vitamin C for women. We're comparing it to 75 milligrams. So can it be 75 milligrams? Yes. The question is, should it be up to 75 milligrams or less than or equal to, or should it be at least 75 milligrams and it can be more? Well, that's what we want. So X must be, or is recommended to be greater than or equal to 75. So that's why that would be a greater than. All right, and then we're not doing 39. We're actually only doing 30 through 37. So that's actually it. We are done. So that is section 4.1. What I would like for you to do for homework is we need to do a little bit of a cumulative review, because we are starting to build on some of the previous things that we've learned in this book. So I would like for you to do the review at the end of this section. So homework is on page 148, number 44 to 53. And these should all be pretty quick. We're reminding ourselves about the commutative and associative properties of addition, the addition property of equality, and then some of the inverse and identity properties. So they tell you what section those are in if you need to go back and reference any information in the sections, but please work on 44 through 53 just as a review. And that's all. All right, thank you so much.